All right, in this video we're going to be continuing with our standard normal distribution. And specifically today we're going to be looking at how you're going to solve these problems using a table in your textbook or a table that I'm just going to show you that I downloaded off the internet as well. We've actually done problems like this, but we just did them on our calculator, and that's kind of the more modern way to do it. But you do need to know the traditional way, and that is by looking at a normal distribution table. So we're going to dive into that in a few minutes here, but I want to start by just doing a little recap. So first of all, a z-score. So you did a delta math on this. There was a video on this as well. But basically a z-score is a way that you can transform values in any normal distribution to what we call the standard normal distribution. It tells us how many standard deviations that any given value is away from the mean. So a z-score of 1 means it's 1 standard deviation away from the mean, 1 standard deviation bigger, that is. If it was a z-score of -2, that would be 2 standard deviations smaller than the mean, and so on and so forth. As I said, positive means above the mean, so a z-score of 1.7 would mean 1.7 standard deviations above the mean, and if it was negative, that would be below the mean. So a z-score of -0.5 would mean 0.5 standard deviations below the mean. Okay, so hopefully that's clear on what a z-score is. I know the last video explained it a little bit, but let's just say, for instance, you had a mean of 30, right, and you have a standard deviation of, let's say, 5, and you calculated this, and you got a z-score. You had some observed value, and you got a z-score of, let's say, -1.2. So what this is saying is your observed value is 1.2 standard deviations below the mean. Since our standard deviation is 5, we could actually find out our observed value. We could say x. That one, we'll call that our observed value, would be 30, because our mean, minus 1.2 times 5. So if we did the quick math on that, well, 1.2 times 5, that's actually going to be 6. So it would be 30 minus 6, which is 24. All right. So if you wanted to know what value is -1.2 standard deviations away from the mean, it would be 26. All right, sorry, how if I could do math, 24. All right, there we go. All right, so again, just a little recap. What the standard normal distribution is. It's a normal distribution with the mean equaling, you fill in the blank. That's right, 0, and the standard deviation being, you fill in the blank, sigma equals, that is right, 1. So basically when we standardize something to the normal distribution, get the standard normal distribution, it changes the scale of this distribution. If the mean was 30, we kind of scale it down to now the mean being 0 and the standard deviation being 1. Now we can solve this using a table or a calculator. We've already done this. We'll probably look at that again. Today we're going to be focusing on this table method here. The table value that we're going to look at represents the area under the curve to the left of the z-score. And we'll be using this a lot and I'll illustrate. Again, it represents the area under the curve to the left of the z-score. So if we look up a value for z equals 1, that means the area under the curve to the left is whatever that decimal is. And also remember with the standard normal distribution, the total area equals 1. Okay, it's like 100%, right? Total area always equals 1. This table of values is going to start on page A22 of your textbook. So if you've got your textbook, you can look at that. If you're looking at the digital version, flip over to that here. The digital version, it's actually at page 758. So if you just type that in, your digital version of your textbook, page 758. Oops. All right. Page 758 digitally. And we'll talk about how we're going to interpret that in just a sec. All right, so how to find an area. We're going to be doing some problems in just a second here out of your textbook, and this is going to be what your assignment's going to be like. We're just going to be finding areas to the left, to the right, between different z-scores. And then in the next lesson, we'll talk about some practical applications of this. So like looking at real world problems and applying these skills. But this is what we're going to be doing, finding like the area to the right, to the left, or the probability that it's less than some given z-score. So first of all, we need to do is find the areas on a table. And the first thing that you would do to find an area would be to calculate the z-score. We're going to be given all the z-scores already. Because again, all the problems we're going to do already gives us a z-score, so we don't have to do that today. Then we're going to look up the corresponding table value. So we're going to go to our table, and let's say, for example, our z-score is 1.2. So what we're going to do on our table, there's a positive and there's a negative table here. So this looks like the negative values you can see here. So this is for z-scores less than the mean. All right. If we wanted a z-score of 1.2, what we're going to do, you can see down here in this column, this is the z, right? It also goes this way as well. Right. Now, if we want a z-score of 1.2, we're going to go to 1.2 down here first, which is right here. And since it's just plain 1.2, it's essentially 1.20. So we're going to want this value right here, 0.8849. Now, if it had been like a z of 1.25, then we would go over here to the 0.05. So this would be a z-score of 1.25. We would do 1.2 and then go down to the 0.5. So that's how we identify those. We want just 1.2, so that would be 0.8849. Area equals 0.8849. And what this means is it's 88.49%. That's what it's saying. It's saying that 88.49% of the values would be at 1.2 or below. All right, so if we're finding the area to the left of a z-score, that's what we just did. The other way we could say that is less than. So less than mean like to the left. We're just going to take just the straight table value, which we just did here. Now, if we were asked to find the area to the right of a z-score, or greater than, say we want to know the value is greater than 1.2 standard deviations mean, well, we're going to do 1 minus the table value. So if we want to know the area to the right of 1.2, since we know the total amount is 1, we're just going to do 1 minus the table value. So in this case, we would have done 1 minus 0.8849. And then the third scenario is if we want to find the area between two z-scores. So like between, z equals 1.2 and z equals negative 0.5. Then we're just going to do the bigger one, larger table value minus the smaller table value. So these are the three scenarios that we'll go through. Shouldn't be too challenging after we do lots of examples. Should be pretty straightforward since. Just note that the table value is always the area to the left or less than. So if I were to draw an illustration of, here we got our mean, remember doing this, remember the mean is 0. So a z of 1.2 would be somewhere over here. And then the area to the left of that, all of this would be 0.8849. And then so if we're looking to the area to the right, well, that would be the right here would be this side, which would be 1 minus 0.8849. So hopefully that makes some sense. All right, let's go ahead and just calculate some problems. You're going to be doing the evens to these. I'm going to just run through and do the odds. On all of these problems, you do need to shade the corresponding area under the standard normal curve. So it doesn't have to be an amazing picture. Just want you to draw a quick picture, indicate what you're doing, and find the answer. All right, so for example, the first one, I'm just going to draw a really small one. For a z-score of 0, well, that's actually going to be right in the middle. It's the mean. And less than, which I think I skipped. Sorry, I skipped that one. The same thing. We're going to draw it. This one went one too many slides. This one's to the right of z equals 0. So z equals 0 is right in the middle. And to the right is going to be shading over here. So what you're going to do is just draw a little picture like that, put 0, and then shade to the right of it. Now to find this z-score, you might actually know what this one is already based on previous stuff. You should know that that's half of half of the value, so it's going to be 0.5. But I'll show you how to find that. So what we're going to want to do is 1 minus the z-score of 0, right? I guess we could say 1 minus z of 0. So that's going to be 1 minus. And to look up the z-score of 0, well, it's actually just right here. 0.0 is just 0.5. And if we had looked on the other chart as well, it's going to be less than both of these. I believe, yep, 0, 0. It's 0.5. So there's 0.5 on each side. So this is actually an easy one. It's going to be 1 minus 0.5, which is 0.5. Okay, if we're asked to find the z-score left of negative 1.32, so we need to draw a little graph there, put 0, and then negative 1.32 is going to be somewhere over here, and shade it. So that's going to be this area. Again, I do want you to draw all these pictures. It's not difficult. Just do a small little sketch there. And then you're going to look up the value, negative 1.32. So let's flip back to that. Negative 1. Clear all this stuff here. Negative 1.32. You're going to want to maybe zoom out a little bit here. All right. Negative, so you're going to go to negative 1.3 first. It's right here. And then the 0.02 column. So you trace this one down, and it's right here. Negative 1.32 would be 0.0934. That's what you're going to write. 0.0934. Right. If we were asked to, again, to find a right value, so like, say, number 19, let's draw a little normal curve, put 0. The right of negative 1.22, negative 1.22, right, is going to be shading this way. And we're going to look that up. We want to do 1 minus the z value of negative 1.22. It's going to be 1 minus, again, just going to look up at negative 1.22. I'm also going to put this chart, I'll show you here, this one. If you want to use this one, I'm going to upload this onto the classroom website. So if you want to use this one, you can as well. That was negative 1.22. And this just goes in order 0, 1, 2. So negative 1.22 would be right here. So it's negative 1.20, negative 1.21, negative 1.22. So 0.11. This one actually even goes another decimal place. 0.11123. 0.11123. Either or is fine. So then you're just going to calculator 1 minus 0.11123. And we've got 0.88877. So either one that you want to do is fine. All right, and if we were asked for between two values, let's just do number 23. We're gonna just put 0 in the middle. We got a z value of negative 0.218. It's going to be way out here. Positive shouldn't be out as far, but it'd be to the right. 1.34, and we shade between. Okay, so that's going to be that area. So I want to do the bigger one minus the smaller one. So I want to do z of 1.34 minus my z of negative 2.18. So the big minus the small. So if I look up my z of 1.34 on this chart, 1.34. This is 0, 1, 2, 3, 4. So it's going to be right there. 0.99988 minus negative 2.18. So negative 2.1. And then go out to 8. I believe it should be this one. 0, 1, 2. Yep. So 0.01463. So I'm just going to type those in. And you will see once you get the hang of this, it is very easy. It might seem a little bit tedious for you after you get the hang of this, but you do need to draw each of one of these and write out your answers. And the next slide is very similar. advance. There we go. All right, so this one is just stating it basically using less than or greater than notation. Let's actually skip the first one because that's pretty easy there. So let's say this one, whoops. Let me get my pen back out here. Let me. All right, so this one, do 37. Still going to draw a picture, put it at 0, negative 1.2, about right here. And then we're just going to look it up. Let's flip back to the book one, negative 1.2.